In several of the comparing functions assignments, they give you the equation, they give you a picture of a line, or sometimes a table, and they ask you to write the equation of the line. For most of you, I think your go-to method is y equals mx plus b. That's called slope-intercept form, where the m is the slope. Yeah, I wrote out different ways to look at it. If you're looking at it from a graph, the easiest way to do it is just to count the rise over the run from any 2 points you know. Later, when they give it to you in a table, you might want to have the formula subtract the y's on top. That gives you how far up and down rise, subtract the x's on the bottom. So I just thought I'd throw those in there even though I'm not going to use them this time. I'm going to write first the equation of the red line. The red line is y equals mx plus b. And my slope is, I need to find something whole number like this. It's easy to use that one. And maybe again where it touches the next axis, y-axis, but it's not always going to touch perfectly at the y-axis. So I'm going to go with that and say rise over run. I say it goes up 3 and over 1. So my slope for the red one would be 3 over 1, or just 3. Now, sometimes I get somebody who says, what about if I went the other way? What if I started at the top? If I started at the top, I'd be going down 3 and 1 in the negative direction. So my slope would be negative 3, negative 1, still turns out to be 3. So I'm going to put this 3 into my equation here. And then I also need to deal with my slope. Sorry, that is the slope. I need to deal with the b part. And the b part is the y-intercept. Where does it touch on the y-axis? So if I look at this graph, I can see it touches the y-axis right here. Looks like 5 squares to get to 5, so I'm numbering by ones. This is 6 plus 6. That is all they're asking for on that line. Let's look at the other line. Let's look at the blue line. Y equals mx plus b. I think I'll find the y-intercept first this time. This one touches the y-axis down here at negative 3. So minus 3 on the end. And I want to find my slope to some point that looks like it's a nice whole number here. There we go. So if I start at the bottom and I want to go the rise, well, let's start at the top. The rise is 1, and the run is 2, but it's going downhill left to right. So it's going to be a negative 1. Negative 1 over 2. If I had started at the bottom, I would have had a rise of positive 1 and a run of negative 2. But a fraction with a negative on the top is the same thing as a fraction with a negative on the bottom, so I have the same thing either way. That's probably the easiest way to write an equation of a line, but in some of these comparing function ones, they ask you to write the equation 2 different ways. So I'm going to also do point-slope form. Point-slope form is y minus y1 equals m times x minus x1. Let's do the red line first. Y equals, whoops, not y equals this time, y minus y1 equals m times x minus x1. Y minus x minus, okay. For my slope, and we already found the slope of this one on the other page, but I'm going to find the slope again using any 2 points here. But don't choose something that's in between. It wouldn't work very well to say, oh, I'm going to start here and go to here, because you couldn't count those points very well. So if I start here, I can say that my rise is 3, and my run is 1, and my slope is 3 over 1. Sometimes when my stylus gets too close to the edge, I have a hard time writing. Just 3. So I'm putting 3 right there into my equation. And then my x1 and my y1 to be any known point. It looks a little awkward if I choose one that has zeros in it, so I'm going to choose this one right here. This point is at -1 sideways and +3 up. So that will be my x1 is -1, minus a -1 is going to turn this into a plus, and my y1 is 3. I don't need to multiply anything out, but if I had done this one first, I could certainly have multiplied it out and got the y alone. Would have turned into the same equation I have over here. And this equation could look slightly different if I had chosen a different point on that line. If I had chosen down here somewhere, my equation would be y minus, still 3, x minus, and I could have said take this point down here, which is -3, -3, minus a -3, minus a -3. That's just another equation for the same line. Point-slope form, you can take any point that you know. It doesn't have to be the y-intercept. When you're doing this one, you have to figure out exactly where does it touch the y-axis. And if it's not a whole number, that can be a pain to work that out. But if you choose to do it into point-slope form, even if they wanted to have it into slope-intercept, you could do this and then distribute and get it into the other form. Let me show you how that works. I could do y plus 3 equals 3x plus 9 minus 3 minus 3, y equals 3x plus 6. Same equation I have here. But that's not what they're asking for here. I already did it the other way, so I'm going to pause it and get rid of that. You only really need one equation for the red line in point-slope form. Let's do an equation in point-slope form for the blue line. Y minus, my equal sign was looking like a Z, x minus, and I'm going to find the equation of the line by doing slope first. Choose some place where we can see our slope nicely. I kind of like this one. I just want to choose something different from what I chose on the other one. I'm going to use this point and maybe this point. Just because I feel like saying, what if you don't see the ones that are real close to each other? That's okay. Some people like to choose the ones where it touches the x-axis and the y-axis because it becomes easy to count the slope. If I start here on the y-axis, I'm going to go 3 up, and I'm going to go 1, 2, 3, 4, 5, 6 in the negative direction. So for my blue line, my slope could be rise of 3, run of -6. which of course reduces down to negative 1/2. Notice I put the negative on top. I kind of like my fractions with the negative on top, but it doesn't matter. If I had just kept it as positive 1 over negative 2, it would be the same. Fractions with a negative on top, on bottom or out in front, all the same thing. I'm going to put it into my equation. I'm just going to put it out in front. Negative 1/2. Some people don't worry about the negative as they're counting the squares. Instead, they just count the squares, make the fraction, and just remember that if you have a line that goes uphill from left to right, that is a positive slope. If you have a line that goes downhill from left to right, that's a negative slope. So for some people, it's easier to count the squares and just throw the positive or negative in front when you're done with it. Then I need some other point that I know. Any other point I know for sure. I'm going to take this one right here. That point is at negative 4 sideways and negative 1 down. Negative 4, negative 1. So my x is minus a negative 4 turns into plus 4, and minus a negative 1 turns into plus 1. There is my equation. Like I showed you with the red one, I could have chosen a different point to plug in. It would look different, but it would still be the equation of the same line. I could take that and multiply it out, and I could end up back with this equation, y equals negative 1/2 x minus 3, and it would still be equivalent equation. I want to look at, jumped forward too fast. I want to look at what if the line's doesn't have a slant to it like this. What if it's just a horizontal line and a vertical line? That is not on the comparing functions 2 assignment, but it will be on some later assignments. So if I have a horizontal line, if I have a vertical line, most of the time, horizontal lines touch only one axis, or vertical lines touch only one axis. This red line right here touches only the y-axis, and it touches that y-axis at 3. So the equation of this line is just y equals 3, and that's all. If I tried to write y equals mx plus b, I would be saying touches the y-axis at 3 and has a slope of 0. You can see that makes this disappear. I still just get y equals 3. Every horizontal line should be like that. If I had a horizontal line right here, my general technique is say, does it touch the x-axis only or the y-axis only? That one touches both. So for that one, I would just need to remember it's touching the y-axis at 0 and the x-axis at a whole lot of points everywhere, everywhere, everywhere. So I would just have to remember horizontal lines are always y equals. Let me look at the green one. Green one touches only the x-axis, and it touches the x-axis at negative 2. So the equation of that line is just x equals negative 2. If I tried to do it with y equals mx plus b, and I said, where does it touch the y-axis? It doesn't. What's its slope? Undefined, because it goes straight up and down. So it's definitely not helpful for that one. I just have to remember, if it goes vertical, it's an x equals line. If it went vertical right here, x equals 0. You just need to remember that the vertical lines, unless they're at 0, 0, touch only the x-axis, so they're an x equals line. The horizontal ones, unless they're right at 0, 0, they only touch the y-axis, so they're a y equals line. I think that's all we really need to know about equations of lines. And if you think about it, you know all this. You probably learned this one 2 years ago, or even before that. Okay, let me know if you guys need questions on something else in that assignment. I won't answer specifically working out other problems, but I'd be glad to help you with general if you're having troubles. But